Okay, we're still in section 3.1. This is the remainder theorem. So the remainder theorem basically says that if you use synthetic division for a certain value, in this case we're using 3, then the remainder that you get would be the same as if you took the 3 and plugged it into the function. So if we took our value of 3 here and put it in for each one of these x's in our function, and did all that calculations, that would be the same as if we did synthetic division and the answer is going to equal the remainder. So let's see how this works. So for synthetic division, again, we would have 3, -2, 4, and -7. We don't need a 0 because there's no values of x missing. So if we bring down our 3, again, you can put your little multiplication sign there as a reminder. 3 times 3 is 9. That adds up to 7. 3 times 7 is 21. That adds up to 25. 3 times 25 is 75. That adds up to 68. So the value of the function when x equals 3 is 68. And the biggest thing to remember here is your answer when it says either use the remainder theorem or if it says find p of something is only the remainder. So once we get our answer, we don't need any of these numbers if we're using the remainder theorem. All we need for an answer is just 68. Okay, let's look at another example. So here we have a little bit bigger polynomial. We're using -2 for our value, so we're finding p of -2. Again, this would be the same as if I put -2 in place of all of these x's and did all that calculation. But synthetic division allows me to do the same thing much quicker and much simpler. So we're using -2. Again, that's what we're going to multiply by. So bring down our 2. -2 times 2 is -4. That gives us -11. -2 times -11 is 22. Add those together, we get 26. -2 times 26 is -52. And -2 times -57 is 114. So that adds up to 117. Again, our solution is just the remainder. So p of -2 is equal to 117. And that's the remainder theorem. So be sure to show your work on your worksheets if you're choosing to do the remainder theorem worksheet. And we'll see you next time.